Okay, guys, so I'm gonna do another quick stream today, and it's possible that I might stream again later today. So I'm going to continue where I left off. So I was developing a tokenizer for this using my old parser generator, and I did do that. Let's see if I can make this bigger. Trying my best to make sure that you guys can see what's going on. Okay. So I need to, yeah, this is the one. I don't think I can zoom this up, but anyways. Okay, so as you can see, so this was generated by my parser generator from this. So it took this syntax, which is the syntax describing the parser that is going to parse this, and this is the UI application of the parser generator. Unfortunately, guys, I can't zoom it up. So this is it, the algorithm parser generator. You have yeah, I released this thing 2 years ago, so that's how long I created this. So I'm redesigning a new version from scratch to be better. Everything. I'm going to redesign even the UI to be better. Okay. So I pass the parser that I want it to generate. I give it a name, it can be any name, and I give it an output folder. And what I can do, I can make it generate like a source file that I can combine with my project. But for now, I'm letting it generate its own main file, and I'm compiling that and running that by itself without combining for my project. So I'm going to do that for the time being until I'm ready to combine it into my project, right? Because I could remove the main file, I can separate the files, I can separate the header, I can choose not to don't generate the VM, and I can do some other stuff as well. All right, but I'm not going to do that yet. So yeah, this is it. Okay, now how do I exit the magnifier? Oh boy. I don't know how to exit the magnifier. Just give me 1 second, guys. Okay, so the Windows key plus escape. There we go. Just 1 sec. Okay, so Windows key plus the plus sign turns it on. Okay, that's good to know. So Windows P plus, okay, turns it on, and then Windows key plus escape turns it off. Okay, so this is working. Make sure this is big enough. All right, so this is working. So if I run E and actually, yeah, so I run E on the language, it tokenizes the language. So that works, right? All right. Let's see what next we can do. Okay. How about I put support for all the built-in something is wrong. I think I have an error, guys, in this function is missing. I'm supposed to have a page called function and it's missing. So let me fix that real quick. This page is missing. I included it, so it's like I don't know what is going on. Like I don't know why it's not showing properly. I'm pretty sure if I put it in some AI model and ask it to find a bug, it will find a bug for me. I think this is now make HTML. Okay. So let me refresh this. Still not showing. Wow. Why is it not showing? It's not even showing here. It's weird. An operator is not showing either. Action. So after action, oh, operator is showing. Then it should be function and lexer. So is there a bug guide not paying attention to? Let's see. I'm using the parser lexer for highlight, but I haven't implemented the support for it yet. But here it is. Function. So is it? Oh, I call it functions. That's the bug. What I call it here, functions. Yeah, so that's the bug. So I discovered a bug. Okay. So this needs an S. Okay. Sometimes we just need to look carefully, I guess. There it is. Okay, so my goodness, what's going on? I'm trying to increase the page size with Control Plus, and no, it's not working. Or maybe my gnome. Yeah, there you go. So what I think I'm going to do is I'm just going to implement all of these, right? Start with this. Close that. So look ahead. Okay. Okay, guys, I'll be back in 1 second. Thank you for your patience. Okay, so Okay, let's see. In between, then I got is. So I just want to mention something about my old syntax. So the reason why I went with the @ symbol in front of every command is because I did not want it to overlap with any variable that the user might want to create. So if they want to create a action called if or is, they can, because I don't have a keyword called is. But the problem is when the feedback that I get from the people who use the parser generator is that they didn't like this syntax at all. The way I see it, they prefer keywords. And that is why in the new syntax generator, I'm using keywords, right? So if you're parsing a language and you have something in the language called is, you're probably going to have to call it something else, maybe like underscore or all caps, because my parser generator language is going to be case sensitive. Say is action not action kind or action text at action len at action to num. Okay, so these are all functions and they all are going to be tokenizers. Yes, they're all going to be tokenizers. Car, look ahead. All right, 20. See if I can get AI to just generate this quick. I don't know. I think AI has made us lazy because I'm finding it hard to type out all of this out. I want to just throw this in AI and say, okay, just write the rest. AI has made us really lazy. Anyways, look ahead. Order 20. And this number is the priority because all of these are going to match with the identifier. And the parser is going to say, okay, I have these more than one thing matching the same text. That's an error. What should I do, right? Priority tells it, okay, choose this one. And this number that I use is completely arbitrary. The parser is just going to choose the one with a larger number. This defaults to 0, right? This defaults to 0. 0 is the default. I could even put this as negative to mean that it has the lowest priority or whatever. It doesn't matter the number, any number. I'm just choosing 20, and once it also matches with identifier, it will choose these ones. All right, order one of 20. Okay, I already have car. This is a string literal, so I don't need to code it. Actually, I'm wrong. I need to actually code the string. I'll code it last. in between 20 is 20, not 20, kind 20, text 20, len 20, to num 20. Okay, let's code the string. So I was wrong. I need to code a string. So the string is going to be advanced. Right? So it's going to be. Actually, I'm just going to copy string from one of my samples. I know Jason has a string. Here it is, string. What is cars? What? Oh, here it is. Okay. Let's copy string from Jason. And it has. One sec, guys. Okay, sorry about that. So yeah, cars. Okay, I'm going to call it something else. I think I got everything on this page. So let me maximize this again. I don't like the name cars. I'm gonna call it string unit, right? What this is saying is match the first option, backspace any character, or not one of backspace or a double quote. Oops. What did I do? Right. And then it's here, match a double quote, and 0 or more string unit, match a double quote. So that's string, and I'll put it here. Right. So I need to regenerate the parser. So let me do the magnifier again. So as you can see, I come down here, hit generate, generation completed. Right. So now come here, I recompile. So I say gcc long.c. And then I run it again, still works. Now I can add more stuff. So this is not the formal syntax, but I'm just gonna write stuff. Look ahead. One off. Do a empty string. Hello world. In between. Is not right. And what we're gonna do, we're gonna run that. Okay, we need new line, so we need to get new line, right? It's such an important thing. I feel like I should put it up here. Space and new line. I think I actually have a built-in feature for it. I don't need to define something. I think I can go like this. Am I right? Let's see. No, I can't. So if I do this, say it failed. So yeah, can't go here. I have to create a action called new line. I can put it here. I can do it myself like this, or undo at first, right? Or I can do it like this at new line. It's like a built-in thing I made because I use new line so common. So let's generate successful. Build it again and run it. And there we go. So car, we got a new line, look ahead, one off, string hello world, string empty string. In between is not, right? So it's tokenizing very well. So what we're going to do now is we are going to discard new line because we don't need it. Discard, right? Discard a new line, and if I generates completed, and let's build it and run it again. As you can see, the tokenization is not outputting new line. It tokenizes it, but it throws it away. It doesn't include it in the final output. So we can focus on the tokens that we are actually going to use. Good. So far, so good. I like that. Doing good so far. Let's see. What next? Why? I don't even have the next. You see, it's missing from here. I mean, this generation thing is so annoying, right? So let me delete this again and let me rebuild it from scratch. Okay. Okay. Okay, this is going fast. That's what happens when you have a really good parser generator, because even the old version with even the challenges, I would say that it's really good, because I'm blazing through this thing. Okay, I have operators. Let's do operators. Right. So the operators have two forms. It has the form with the closed square bracket, and it goes from left to right, and then it has the regex-like style. Okay, how am I gonna do that? All right, I'm gonna parse these separately, right? Ooh, okay. Um, okay. So we're gonna do operators now. So what am I gonna call it? Actually, yeah, action. One or more. Let me call it one or more. Plus sign. Action 0 or more. Multiplication sign. Action 0 or 1. Question mark. And what I'm going to do is, for the square brackets, I'm not going to create an action for them. I'm going to use them literally like the equal sign. So the open square bracket, and I'm just going to do the close square bracket beside it. And then one or more, 0 or more, 1 or 0 or 1. All right. We got semicolons, right? So we need, okay, I'm going to do that literally as well. Semicolon. Okay. We got the range. Oh, so we need number. And right now, my new Parser generator language only supports counting numbers. So from 0 positive up. So I'm gonna do that. I already have digit right here. So matter of fact, I can just put it right here. And it's gonna be action. Number. It's gonna be either, I'll do that at first, find the first one. It's gonna be either 0, but I feel like a number is gonna come first. It's gonna be 1, still 1 off. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 of that, and then 0 or more of digit, or it's just 0. That's number, right? So I'm gonna need number. Okay, so I'm gonna have colon. I'm gonna actually have colon, and I'm gonna have colon, and then I'm gonna have number. Let's token C. Oh, and minus sign. The minus sign can be a literal minus. Alright. So as I'm coding, I realized certain things, right? Like, because I'm discarding space, right? It's like this. This syntax, the way I want this syntax to work, right? the way I want this syntax to work is that I don't want any space here. I want if the user writes something like that, it gets an error. If the user writes if the user writes something like this, they get an error. If they write something like that, they get an error. If they write something like that, they get an error, right? I want this to be the only thing that's okay, right? I want that to be okay. I want this to be error. But there's a problem because I am discarding space. Because I'm discarding space, the parser will no longer be able to determine the differences between these because it doesn't know whether or not space was there or not because I discarded it. So I wouldn't be able to enforce this, and the user will be able to enter something like this without error. It's like, should I allow something like this? Like, this is what I want to see, but should I allow them to do a space and then that? Right? So this is something that I realize is the pain that I would have to do to enforce this is that I would need to remove the discards from the space here, and then I would have to literally, when I reach the analyzing phase, like if I'm parsing, for example, if I'm going to parse something like this, for example, if I'm going to parse something like this, I would have to I would have to account for space literally. So I have to do this, then I have to do space, 0 or more, then this, then space, 0 or more, then this. I would have to do this, right? I like discarding space because I wouldn't have to write the spaces, but I wouldn't have to write that if I discard the space, and it's easier to write my parser and it looks cleaner. But then what if I want to enforce no space here? The only way I can enforce no space here if I don't discard it. So I think I need a feature. Right? Where even if I discard a token, like say I discard space, I can say, okay, ensure no space. Something like this. I need a feature like this. So I needed to keep track of discarded tokens so I can enforce when I want to ensure the discarded token did not exist in the original text. So this is something I need to put in the parser generator. So let me just add that, a note somewhere. So I just learned that I need something like that. So I'll implement that along the way, because I feel like I want to enforce that these don't have any spaces. I could just allow spaces, but nah, for the beauty of the language, not gonna allow it. Then the curved brackets, I'm gonna implement those as literals. Yep. See what next. I already implemented these. The curved brackets, I'll implement those as literals. I already implemented string. I have the elixir keyword. So some more keywords. Action. Elixir. Action. Action. Token is a keyword. Action. Analyzer is a keyword. Syntax is a keyword. So let's drop those in. These probably should be at the top or whatever. Elixir 20, because they're gonna also match with identifier. Token. Analyzer. Syntax. Right. Okay, what else? Oh, we need to match this symbol, the OR symbol, and the firstly OR symbol, to match those. Oh, we need to match the everything symbol, which is 3 dots. Oh, and I do actually use that arrow symbol. Yeah. Oh, and the comma symbol. Okay. I'm gonna have tokens here. It should be token singular. Oh, I matched the tilde symbol. Oh, discard, reduce, and priority. You're missing priority there. Are also keywords. Action, discard, reduce, action, priority, discard, reduce, that one here, reduce, priority. Okay. Oh, the comment. Right. I need to create a comment. Could be at the top, right? Let me see how I created a new line. It's string. It's similar to string. So comment is gonna be this symbol followed by 0 or more, which is a star. I don't know why I write. I mean, 0 plus, and that worked. Is that all I did? 0 or more? I didn't use a star. Let's see. I guess I have some quirky syntax that I didn't document. 0 or more, and this will be new line, right? Should be not new line, not new line, and that's it. That should work. Let's comment. Oh, I got alias. Okay. Action alias. And I got variable. The thing is, I'm not sure if I'm going to implement all of these variables.
Great.
Parser. I'm not going to implement textval and numval. I'm going to remove these. Say alias. I'm going to implement the parval. Parval stands for parser value. Action. I'm going to implement tabval. Table values. Tabval. These two. I'm not going to implement those two. I got something called scope. Action. Scope. Alright. Let's just implement those. Marvel. Okay, and we're going to do something called an arrow, but I won't implement it yet, right? Because it's going to take some thought process, and I think I rather like have the code implemented and then I start think, okay, how am I going to implement this arrow thing? So yeah. So let's generate our parser, so I can go up full screen now. Okay, let's do this. Let's do one fine. So let's see it generate. See if I got any error. Well, no errors. That's amazing. All right. Then now I'm going to compile it and I'm gonna run it. Okay, everything runs nice. So we can see, look at it, string in between is not comment. The commas, one of comma minus a number, that comment, that one off that minus sign. Okay, good. Now what we're going to do, we are going to come here where we see sample. I'm gonna copy this, copy, and we're gonna come here to the parser. We're gonna place everything with this. So we're gonna see if we can tokenize the entire language. And let's see. Now we have an arrow. Alright, so we have this. Okay, there's a wait a minute. Yeah, this is an arrow by me, right? Because it's not supposed to be backspace, it's supposed to be this. So this is an error by me, right? In the sample, and I need to fix that. Run again. We failed at, oh, we forgot $sign. Okay. So we can implement that literally. Yeah. $sign. And let's go in the language and fix that should be /. All right. Now let's do this again. Oh, we haven't compiled, so every time we edit or parse our language, we have to compile it with a generator. We have to generate it with a generator and then recompile it. Clear the screen and run. Oh, angle braces. Oh yes, and we do use angle braces. Yes, forgot that. And again, I can implement that literally. Generate, compile, run. More backspace error 1811. Let's remove that. No, this is correct. Okay, so the problem is, right? Right, so the problem is we're only acknowledging the backspace inside of string quotes. We need to acknowledge the backspace outside of string quotes. So let's do that. So this is how we do it right now. Honestly, we want to do that inside only when we parse, we tokenize the thing, and tokenize, only when we tokenize the angle brace, we want to do this, but I don't want it. Okay, that's a problem. And this is a limitation of my old parser generator, and that is why I'm creating a new parser generator, basically. That's a problem. Alright, this is my problem. Let me try to explain, right? We have this in our language, right? If you know regress, this is what it would be in regress, but I'm using the square brackets for something else, so I use angle brackets instead. And I also choose angle brackets because I'm going to add some additional features to this that's not going to be in regex, right? So I kind of want this to parse together, but I don't want it to be one single token, right? I still want this to be individual. I pose a great challenge. It's not possible using my current parser generator language, but it's possible using my new parser generator language. So this is going to be a significant challenge, and basically what I'm going to just do to make my life simple, I'm just going to create this action. I'm just going to call it ind for independent escape sequence, independent escape sequence, and I'm just gonna do this a single character, right? Hopefully, and what I'll do, because the end of the day, guys, this is just to get my parser generator, new parser generator up and running. Once I have it up and running, I'm going to use a new parser generator to generate its own syntax. I'm going to replace the parser for my new language that I'm generating with the old parser generator. I'm going to replace it with one that I created using the new parser generator, which is going to make parsing far more easier. So for now, I'll just do that. I'll do that for now. Alright. So generate compile and run. Okay, there we go. I'll be right. Okay, so as you can see now, I am finally tokenizing like the entire language. Tokenizing keywords, with an identifier comment. Oh yeah, this is right. This is right. So yeah, new line. Yeah, this is right. So I'm tokenizing the entire language now, which is great. Something I forgot. For comment, I don't want the comment, so I can discard it. Discard it. Okay, did I generate any comments here? I didn't have any comments in this. Anyways, I could write comment, show it. How and right there it is, comment hello, and now I updated it to discard comments. Generate. Okay, compile, run, and there you go, comments is gone. Okay, great. So far great. I think there was another sample, so I got the ini sample, and this is what semantic predicates. Let me test this real quick. I'll just drop it down here. Great. Everything parse. All right, nice. So it's now time for me to do the analyzation. So this is where I take the tokens and generate syntactic objects, basically abstract syntax tree. This is, I guess, the more fun part. So look at that. Look how many tokens I'm generating. And look how long my parser generator is 100 lines right now. And that's being generous. Yeah. Look at that. Just all that, and I already have a tokenizer. Okay. Time to generate, and I'm going to write the analyzing part here. Okay. Can I analyze? Okay, so analyzer is going to take a while to write because unlike tokenizer is more simpler to write. Let me see. Okay. All right. Let's build it up from scratch, right? Let's take our time. Let's delete everything because we're gonna work on the analyzer now. All right. Let's start here, right? What's the simplest thing? All right, where we start? Let's start with these guys, right? This is called an action, or a grammar action in detail, but action for start. I got it right here. Action. Let's go on action. Action. A grammar action, or simply action, is the definition of a parsing action. It can be a character parser or a token parser or both. The type of action is result. No, this is old design decisions. This is outdated. I have to update this. So, but anyways, here you have animal equal cat. So this is a label to the action, and this is what the action does. The action is matching any text that matches the literal cat exactly. So this is an action. So let's start with this, right? Here. Okay, go, and we can run that, right? Animal, we tokenize it, animal, the identifier, the equal sign, and the string cat. Now we're going to develop our, I have too many things open. Let's close this. Don't really need this right now. I can close this. I don't need this. Right, I'm going to look at this. So we need to create a syntax space, and I'm going to create it here. Syntax space. I don't know if it's allowed to come after the config, but we'll see. And I'm creating an action. So let's go. Action. Right? And the action has an identifier followed by an equal sign. And now this is, I guess, the hard part. I'm gonna say it's followed by a option, and bear with me, right, with this. The reason why I say it's followed by an option, if you go under language, I think, no, There's something called jargon. Oh, I think it's under language. No, it's under action actually. Here it is. So parts of the action can be considered series or options. When it's in order like this, separated by spaces, it's an series. When it's separated by the bar, it's an option. But regardless of any combination you use, it can be considered an option. All of this is an option of 3 series, 1, 2, 3, right? I know this because I parsed this before using Flex and Bison. So we're gonna do a option, and guys, this doesn't need to come before this. It can come in any order. I'm just doing it for ease of eyes. An option, right, is, I'll tell you what. An option is a series followed by 0 or more, the bar followed by a series, right? Yes, so that's that. Okay, we need to fix this though. All right, for now we're going to deal with it simple. Action series is a unit followed by 0 or more units, right? That's a series. All right. Action, right? A unit is going to be many things, and I'm going to do first so that it parses as fast as possible. Pick the first one it parses, and I'm going to put it on separate lines because it's going to be many things. This can be a string, and just like that, we have a first analyzer. We're not done yet because after defining this, we have to define the entry point and the object point. Okay, so at entry point is going to be for now, let's just call it action. Action is not the real entry point, but I'm just going to define it as action for now. And object point. What is object point? Object point is the terminals and the non-terminals that will be saved in the abstract syntax tree. That is what object point is. And pretty much, okay, let's see. We are going to save action in the syntax tree. We're going to save, we don't need to save the option, right? We just need to save the series, right? Because if we see a list of series, we know that there are options to each other. We don't need to save the unit, we just need to save what is in the unit. So for example, string, we need to also save identifier. So we need to save, all right, let me put this on one line. We need to save the unit. We need to save the identifier, right? Let's see if we can generate now or if there's any errors. Let me magnify. See if there's an error you see it pops up. Wow, no errors. Oh my goodness. All right. Let's compile and let's run. And there we go. So So we tokenize it, and now we analyze it. And now you have an action at 1-1, which has a identifier as a child and a series as a child, and that series has a unit. This is wrong. What? Oh, I put unit, but oh, wait a minute. Oh, I see. I didn't mean this. No, not unit. I don't need unit. Identifier and string. There we go. Let's regenerate. Okay.
Just leave.
Compile. There we go. All right, so we got an action. We have the identifier, okay, which is animal, and then we have the series, and it's see, it's one series, so it's an option of one because it's only one series, and the series is a string called cat. So basically this is what I'll be getting as an output when I parse my language, and now I will write the code to interpret this, right? That's what I'm going to write the code. So I, using the entry point and the object point, I decide what gets saves in the abstract syntax tree. So if I want to make my life easier, I try to direct the generation of the abstract syntax tree in a way that is easy for me to manipulate, write my code to interpret abstract syntax tree. So this is what the parser generator does in a nutshell for you as fast as possible. And then this is, it makes writing a parser easy and quick. And the hard part now is analyzing the abstract syntax tree. But yeah, this is good so far. Right. So I did mention there are some things I need to fix, right? So one of the rules is that for an option, it can either be this or the other one. You're not allowed to mix or match the two different ors. So what I'll do like at first here, and I'll put a bracket around this, and I'll generate another one, and I'll put it here, and I'll use this one. Okay, that's one thing. Okay, so we're good there. So I put first here, and you can have string, you can have identifier, you can have let's call it directives, and we're going to create the directives and action. No. Alright, let's not jump the gun. Let's, because I think I have to build something for that. Oh, there's another thing here. The arrow thing. forgot that. Do that as a literal. Ooh, like I said, the syntax parsing part is going to be the hardest. Tokenization is the easier part. This part is going to be hard because I'm going to have to build this up, right? Okay. So put some space between that, and for now, I'll let the entry point be action, and I'll take my time and build the object point stuff, and I'll focus on this part, just the action part, until I completely support every possible syntax in the action, and then I'll build up to other features such as the lexer, the token, and so on and so forth. Right, I'm going to end the stream here. I think I actually streamed longer than I expected. I wanted to stream for 30 minutes max, but I end up streaming for over an hour and a half. Okay. Thank you for watching my stream. I appreciate y'all. Have a great day.